Hello, good morning, good evening, good afternoon. Welcome to our third edition of a Tech Talk series with ConSol, a cloud native story. Today, we are going to talk about continuous integration and continuous delivery and GitOps. So I'm very happy you are joining us today. My name is Marian. I'm going to be your host today. I'm part of the developer advocacy team here in Germany, and I'm from Berlin. So if you like to tell us where you are joining us from, please feel free to do that in the chat. I'm going to monitor it. And if you missed out on the last two sessions with ConSol in 2020, where Marco Bungard actually told us how to develop reactive applications with Quarkus and securing them with Keycloak, I'm going to post the links to the replays in the chat in a minute. So if you haven't had the chance, take a look. Today, I have Sebastian Tiggekamp with me. Sebastian is a DevOps engineer and a DevOps enthusiast, and he's always looking for ways to optimize the build and deployment processes and workflows. And I believe most of us are in the situation that we need to deliver value to our customers and clients in an ever faster way, while still remaining very high quality releases. And with the rise of cloud native development, we also want to leverage the advantages of cloud computing. So how does it all come together and how can we actually achieve it? Sebastian is going to tell us in a minute how it can be done with cloud native CI/CD pipelines. And before we jump into your session, Sebastian, I want to say a couple of words about IBM Developer and the Crowdcast platform itself. So for all of those who are new to our community and those sessions. So IBM Developer is IBM's initiative to reach out to developers of our partners, our clients, and in the ecosystem like you. And we do that in three very important pillars: code, content, and community. With respect to code, all of our developer advocates and experts are constantly creating new code snippets in form of code patterns around topics like hybrid cloud, data and AI, and open source and new technologies. And all of those code patterns can actually be found on developer.ibm.com. And I'm going to post the links in a minute. And the second pillar is content. All of our developer advocates are also constantly creating new blogs, new videos, and are very active on social media. So please feel free to reach out to us. You can find our developer advocates at developer.ibm.com/community. I'm going to post the link. And this brings me actually to our third pillar, community, which is you. We accompany all of our digital work and our digital content by free face-to-face developer activities. And if you are interested in more events like this one, we post our local activities on our main platform at Meetup at IBM Developer. So if you haven't had the chance to join our community, feel free to do so. With regards to the Crowdcast platform, if you have questions, please state them in the Ask a Question section so we can make sure, and I can make sure they are getting answered, because if you post them in the chat and it's very busy, sometimes they get lost. But I'm going to monitor both. So with that all said, I'm going to give the word right to Sebastian. Sebastian, welcome. And I'm going to put myself on mute now.
Okay, thanks for the introduction. Hi, everyone, and welcome, and thanks for joining us today. Let's just talk a little bit about cloud native CI/CD and GitOps and how it plays together. I will directly share my screen and open my presentation. But in general, I will just show a few slides today. Most of the time today, we will do a live demo and really deploy an application to OpenShift. Actually, we will deploy the Quarkus application that my colleague Marco showed in the last talks. And hopefully the demo will be fine today. Yeah. So first of all, just quick, my name is Sebastian Thielkamp. You already heard it. I'm working at ConSol, and yeah, we are doing a lot of cool stuff here at ConSol. I just opened quickly the slide with our portfolio. So we're actually working with the things that I will show today. So in case you have any questions, just feel free and contact us. And now let's dive into the agenda. So I will give a short introduction on what is cloud native CI/CD and GitOps. Then we will have a look on cloud native CI/CD, which today will be the Tekton CI/CD engine. And then we will have a look on ArgoCD as the GitOps engine. And then we will dive into the demo and try to deploy the application with Tekton and ArgoCD. And at the end, we will have time for questions and answers. But in general, if you have questions, just put them in the in Crowdcast in the Ask a Question section, and I will try to answer them then in between the talk. Okay, so cloud native CI/CD in general is an approach for building and delivering cloud native applications. And we try to leverage the advantages of a modern cloud computing, which, for example, can be the part of scaling. So we can also try to scale our CI/CD setup and not only our application. And yeah, so we will try to apply any advantage of the cloud to our CI/CD engine as well. Just quickly, what is continuous integration? I think most of you will know it already, but in general, it's a practice where developers integrate their code in a repository continuously and preferably several times a day. What is GitOps? GitOps, described in one sentence, is a tool or engine or approach that is syncing the states between a Git repository and the target, let's call it cluster. So most of the GitOps solutions are designed for Kubernetes because we need to have a system that can be described declarative, and Kubernetes is currently the most popular one. So we will see exactly what the GitOps ArgoCD engine will do. But in general, it's about applying any change to the Git repository automatically to the target cluster. One of the tools that we will work with today is Tekton. It's a cloud native CI/CD engine. It's still under development, but it's already quite popular, and also Jenkins X, which is the cloud native Jenkins version, is built upon Tekton. So generally, Tekton Pipelines and the pipeline that I will show you later, they are cloud native. That means they are running on Kubernetes natively as custom resources. A Tekton pipeline is decoupled, so we can use one pipeline to deploy to any Kubernetes cluster. Also, each task in a pipeline can run isolated and also can be reused for other pipelines. What exactly this means can be seen in the demo. What is Tekton based on? So the components of Tekton, those are just a few. We will see some other in the demo setup. But the main components are tasks. So a task is one or more steps that is executed to do something that we define. So each task consists of one or more steps, and each task is then executed in a pod. And inside the task, each step is executed in a single container. A task run in general is then the definition on how to run the task that we defined. So usually a task will, usually a task has some parameters defined, and in a task one, we will set the values for those parameters so that we can use the task and run it differently for our different workloads. The same goes for pipelines. In the end, a pipeline consists of several tasks, and a pipeline run will execute the pipeline with the given inputs.
So, Sebastian, there's already the first question, and I thought
Okay.
it might be the flow might be good. So, Andreas would like to know, and he would be interested in your opinion regarding trunk-based development versus feature branches and pull request ceremony. So, how do you deal with Docker image promotions to production?
Okay. So, multi-component question. Yeah, first of all, well, that's a good question about trunk-based or feature branches. I think everyone handles it differently, and it's also a little bit a compromise in the team. So let's say what I usually work with are short-lived feature branches that are then merged into the trunk. That is what I'm comfortable with. Trunk-based development can be quite fast, but it's also, if something, let's say goes wrong, it's quite messy to debug. The second question was about the promotion of the Docker image. Well, best case, or usually what we should do is we only build the Docker image once, and then when we promote it to production and it needs, and it differs to the other stages, it should only differ regarding some parameters, but the image that is deployed to production should be the same on production and the other stages like dev and UAT, for example.
Cool, thank you. The second question I will hold off because I saw your next slide is might gonna be talking about that. So just go on and.
Okay. As the GitOps engine today, we will look at ArgoCD. It's actually, I think, the mostly used GitOps engine right now. The other big one is Flux. But ArgoCD is, at the moment, the one with the most features and a really good solution. So ArgoCD is a GitOps-based continuous delivery solution. And the main component of ArgoCD is are the applications. But I see, okay, it's, sorry, let's go with the next point. So usually ArgoCD deploys our Kubernetes manifests to the target cluster automatically based on what is defined in our Git repository. And it does so in several ways. So we can specify different applications or definitions on how to deploy our application to Kubernetes. For example, it can be customized applications, it can be Helm charts, or plain YAML files, and there are even some more. But today we will just use plain YAML files for our short demo. So generally, ArgoCD consists of applications, and those applications tie a Git repository to a Kubernetes cluster. So we define what files in our Git repository should be deployed to Kubernetes, and then we can define how it should be deployed. So it can be done automatically once there's a change, or we can decide to just be notified if there's a change and then deploy it manually. And also one of the features that is good to know is that ArgoCD is multi-cluster, can do multi-cluster setups. So you can run ArgoCD on one Kubernetes cluster, but you can then from this cluster also manage other Kubernetes clusters or deployments on other clusters. And also there's a multi-tenancy support in ArgoCD. By defining several so-called projects, we can separate our projects and assign the rights that each team needs, and then have a separation between those applications. Okay. Do you want to ask the question now, or shall I go on?
The question has actually, I think you already answered it. The question has been Tekton Pipelines versus Argo workflows. Would you build the container with these options? I think you just answered it. The answer would be yes, I guess.
Yeah, Argo workflows is it's not the ArgoCD that we will see. So you can also do CI with Argo workflows, but the time I spent on this was gave me the opinion that it's easier to do it with a dedicated CI solution like Tekton, and rely on ArgoCD just for the CD part, so for the continuous delivery. That's my opinion.
Okay. And do you know if multi-clusters with tenants can also be done, like the CI/CD part, can it also be done with a serverless approach?
I'm not sure if I really get the question.
Okay, so the question is multi-clusters with tenants. Can there be continuous integration, continuous delivery with a serverless approach?
Good question. No opinion on that right now. Sorry.
Okay, we put that back for now.
Yeah. Okay, next slide. Yeah, I prepared the workflow that we will have a look on today in the demo. So let's just quickly go through it. We will push some changes to our application repository. And then a webhook will trigger the Tekton pipeline. The Tekton pipeline will build the application, and it will then push the container to the container image repository. So that's this part. But it will also update our deployment manifest with the newly created container image, and it will push the manifest to our manifest repository. And once this is done, the ArgoCD application for our Quarkus application will recognize that there's a change in our manifest repository. It will pull the manifest and the new container image, and it will then update our Kubernetes cluster. Okay, so it's already the demo time. I will jump back to this slide, but because maybe we want to go back to it during the demo. So we will start with more or less newly created OpenShift platform. The only thing that I've prepared is I've created some namespaces that we need. I applied some secrets that we need, for example, the Git secret, so that our pipeline can access our Git repository, and also the secrets for our Docker registry. But apart from that, I've not done anything yet. So we will do everything we need to do from scratch now. But first of all, let's have a look on what we will actually do with Tekton and how our Tekton files look like. So we have one file which is called the Quarkus app trigger template. In this trigger template, we have different components. I will start at the bottom because in this case it makes more sense. So actually what I've defined here is a route which points to the service for our event listener. So we need this to create the webhook in GitHub so that once we push any changes to our application repository, it will automatically trigger the Tekton pipeline. So that's this part. Then we have the event listener. That's this part here. The event listener is the part of Tekton that will receive the push event from GitHub. And I have set up some filters in here. So in the end, it will only do any action if the GitHub event is a push event. And it needs to be a push in the master branch. If this is given, then we will define some variables that we need for our pipeline. This is done with the so-called bindings. And those are the trigger bindings that we have. This is one, so this is the one for our deployment of the application. And here we need some variables like the URL of our Git repository for our manifests, the revision, which is the master in our case. It will need, okay, this is a bit, what we do in the pipeline is, I've mentioned it in the workflow, we will update the manifest with the new image that we created. So we will need to know where our deployment manifest is and also which part of the manifest we want to update. So in this case, we want to update the container image. And that's something that we will pass to the pipeline. The other trigger binding that we have is for the application itself, so not the manifest, but the application. We have the Git repository 2 application. We have also the revision. We have our image that is defined. So it's the IBM Quarkus demo image, and then we will extract the commit ID from the push event that the event listener receives. And then we have some other variables like the path to the Docker file for building the Docker file, the Docker image, sorry, and the Git user and Git email. Those bindings will then be used in the event listener for the trigger template. So this looks a bit messy. The template actually just receives every parameter that we've defined in the binding. And then we create a pipeline run. So we pass everything that we've defined in the bindings and call the pipeline with those parameters and values. So actually, it's just a list of parameters that we pass. So we now can have a look at the pipeline real quick. The pipeline should reflect every step to build and deploy our application. Or in this case, it's only the build because the deployment is done by ArgoCD. So the pipeline, we have all the parameters defined, and then we have some tasks. So first of all, we will fetch the application from Git but we will also fetch the deployment manifest from Git. In the next step, we will build the image. So here we will use the image parameter that we've defined and the path to the Docker file. And in the next step, we have the step where the task where we will replace the image in the deployment YAML. And at the end, we will push the changes to our deployment YAML into the Git repository so that ArgoCD can pick it up. Generally, in in Tekton, there are some predefined tasks that we have in OpenShift, in the OpenShift Tekton setup, like the build AH task that we have here. It's a cluster task that is already given by the OpenShift Tekton setup. But we also have some tasks in here, like the replace image task, which refers to the update image in YAML task that I defined myself. So we are free to define any task that we need. What we usually need in the task are some parameters, and then the steps what the task should do. And for that, we always need a Docker image. So we have, in this case, this image that is used, and then we will pass some parameters to this image. So we are quite free to add any task that we need to have. So we can create our own Docker images and use those for any task, or we use some of the images that are out there to do it.
So Sebastian, Andreas is actually having a question. He's saying, I guess the automated manifest update is for the dev cluster only. Do you use some manual triggered pipelines for updating the prod manifests? Because it looks like single cluster only in the demo.
The demo is single cluster only, yes. We are not doing any promotion to production today. I think the most used approach today still is to update the prod stuff manually, or to trigger it manually at least, and not do it automatically. I think this may shift in the future a little bit more to be automated as well. But of course, you need to make sure that everything is robust and working as you expect. But yeah, especially if you are using approaches like GitOps that are quite new, you may want to start with only doing automated steps in dev, and then at first do the prod updates, at least not automated with ArgoCD, for example. So you can also let ArgoCD notify you that there are changes. You can then review those changes and then trigger the deployment manually. So.
Thank you, Sebastian.
Okay, so that's the Tekton setup, and the ArgoCD setup we will have a look on once we have it installed with OpenShift. So with OpenShift, it's quite easy. There's the operator hub, and in the operator hub, we can look for the ArgoCD operator. Okay, let's install the operator. We leave everything as default. We just need to define the namespace. I've already created the ArgoCD namespace. And then install it. Then in OpenShift, you also have the, it's quite new, you have the built-in pipeline setup, but it also needs to be installed with the operator hub. So when we search for pipeline, we can see the Red Hat OpenShift pipelines operator. So we can see that it's using Tekton as a solution. So we will also install this. And actually, apart from the OpenShift version, we can leave everything as default as well. So we already see that ArgoCD was installed successfully. Now we need to create an ArgoCD instance. This is also quite easy to do for the basic setup. We just define a name. In our case, I need to have a route that I can use because we want to have a look at the UI, for example. And the rest is, for now, also the default.
Sebastian Petty is actually asking, how do you actually write all these YAML files? Do you copy and paste with try and error, or do you have IDE support?
Yeah, Tekton YAML files to write can be quite a challenge, especially if you are starting and you have a complex setup. So I think there's a reason why there's Jenkins X building on top of Tekton and abstracting a lot of stuff. I personally currently write them myself because in that way I do learn the most I can learn about it and see what I'm doing wrong. And it's also a good experience to write your own tasks. Yeah, but in the end, it's YAML files, and once you have the understanding on how Tekton works in general, it's possible. I actually have not yet looked for any IDE integration, actually.
Okay, and why you have actually spoken about Tekton? Pity also asked, can you explain the difference of classic CI solutions like Jenkins, TeamCity, with cloud-based CI solutions like Tekton? Like, what would be the benefits and the drawbacks?
Well, the good thing about Tekton is, and ArgoCD as well, is that they are running natively on Kubernetes. And that's not the case for the plain or the Jenkins CI/CD solution that we know and use for a long time. There you can deploy 2 clusters, but you are not you don't install it on a Kubernetes cluster. And well, that gives you the advantages that any application on Kubernetes can leverage. We can manage it the same way that we manage any of our applications on Kubernetes. We can scale it easily. We don't want to wait for pipelines to be finished in 2 hours if we need more resources. Especially in a cloud environment, it's easy to just scale our Tekton setup, and then the pipelines will be faster. We can run a lot of pipelines in parallel and let it scale up and down on demand.
Thank you. And one more question, then you can go on, because the other questions I will ask you later on. Do you actually have the possibility to debug those containers? For example, the one you created for the tasks you defined in the update YAML task YML?
Yeah. So when you run the Tekton pipeline and anything goes wrong with the specific container, it usually is a bit difficult to debug, because it will be if there's no real log output, then you don't have a good way to debug. But it's an image that I can run locally and test with the exact same parameters on my machine, for example. So usually any task here is using a Docker image that I can run locally and check if it does what I need, and then add it to the Tekton task.
Thank you. Now we can go ahead, and I'm gonna. There are a lot of questions, Sebastian. So you see, the crowd is really curious in what you are showing. So you might just go on, and then I'm gonna ask a couple of questions later on.
Okay, then I try to be a bit faster than planned because yeah, the demo will take a few minutes. So now ArgoCD is applied and Tekton is applied. So what we now want to do is we want to access the ArgoCD UI. Therefore, I will get the route. So basically, anything that I do now in the UI can be done with the ArgoCD CLI and Kubernetes or OpenShift CLI. For the demo purpose, I'm doing it in the UI because it's usually easier to follow. But anything that we set up today can also be set up with YAML definitions and configs and all the stuff. So the ArgoCD instance was created. We quickly need to get the password for our ArgoCD instance. And then we can go ahead. So this is our ArgoCD web UI. We haven't done anything with it yet. So the first thing that we need to do is we need to define some repositories. So let's go ahead and define our repositories. So first of all, we want to ArgoCD to apply our Tekton pipeline and everything that is needed for the pipeline so that we can deploy our Tekton CI/CD setup with ArgoCD in a GitOps manner. So once we change anything in our pipeline, it will be deployed by ArgoCD. And then we need the URL of our deployment manifest, and we will pass the username and the token. So we can see that the connection is already successful, and we can go ahead with more configuration, which is not much. So what I quickly need to do here is in the default project that we will use today, we need to quickly exclude some resources that we don't want to be monitored by ArgoCD. So those are the role bindings. For the demo purpose, I don't want to have them to be applied automatically or synced. And for Tekton, the pipeline runs cannot be part of the ArgoCD sync mechanism because each pipeline run has a different name and it's not defined in the Git repository. So each pipeline run would be shown as an auto sync event, and yeah, that's a bit ugly. So we will just exclude it. So first of all, we want to have our pipelines be applied. So we define a name. Let me make it a little bit bigger. We use the only project that we have set up. It's a default project. And then we can choose either sync it manually, like we maybe would do it for production clusters, or let it be synced automatically. Then prune resources means if a resource is not defined in Git anymore, then ArgoCD is allowed to delete it from the cluster. And the self-heal option is an option that does not allow any manual changes on the cluster. So if I change the deployment manifest on the cluster directly, and it's not in the Git repository, the change, then ArgoCD will just roll it back to what is defined in Git. At the source, we will use our previously defined repository URL, and our Tekton resources are in the pipeline folder inside the Git repository. Then the cluster is the cluster that ArgoCD is also deployed on, so that's the only cluster that we currently have. And the namespace, we use dev pipeline as namespace. So if I have applied everything correctly, also before the demo, then this should now sync successfully. So we can see that ArgoCD is directly syncing everything that is in our Git repository and applies it to our OpenShift cluster. So we can see our route, we can see the pipeline, we can see our custom tasks that we defined, the event listener, and so on. So now what we need to do is we need to have a look at the route that was just created, and we need to copy it to, okay, I've actually closed the tab. We need to put this URL in the GitHub webhook for our application repository so that we can push changes to Git and ArgoCD will recognize those changes. So that's already done. Now we will set up the second application, which is the one with the deployment manifests that are applied. It's again the default project. We will sync automatically. This time we will use the other repository with the deployment path. And the namespace is dev-quarkus. And create the application. So I can quickly show actually what is in the Git repository. It's just those two files. It's a deployment where we define our image, and that's nearly everything there is to it. And the service that we want to use. Just quickly, so that you've seen it, the applications that we just created in the UI, we can also, like I already mentioned, create it with the YAML manifest. So for example, this would be the application that we just created for the deployment manifest. So one quick look at ArgoCD, and our application is already deployed. So let's go ahead, and what we want to do now is let's have a look at our workflow. We want to push the change, push some change to our application repository and trigger the Tekton build. So let's go to, we're already there. Just to have it simple, I will just adjust the Docker file. And I will push the change. And what we see now is that in OpenShift, in our pipeline section, we should have a pipeline run that was triggered. Exactly. So we are in the stage running. Damn it, I forgot one step. Maybe we are fast enough to do it on the fly. I quickly need to add some secrets. Okay. So if it's failing, I know why it's failing. So the Tekton pipeline is run as a service account, which is called pipeline. And for this service account, I just added the credentials for the Git repository and for the Docker registry. And
Sebastian,
now
also something is failing in the chat.
okay.
There have been some mentions that there might have been a typo for the cluster row binding instead of row binding.
Oh. Okay, but it seemed to have worked.
Yes, exactly. So that's why I didn't mention anything.
Yeah, otherwise we would see it here. I guess I have defined it for. Sorry. It looks fine. Roll bind. Okay. Nevertheless, the deployment was triggered, and it will take some time. So maybe that's the perfect time to answer some more questions now.
Okay, get yourself prepared. There's a lot. So actually, Simon precised his questions around the multi-cluster with tenants. So I'm going to repeat that one from the beginning.
Okay.
Multi-clusters with tenants, can there be CI/CD with a serverless approach? For example, at AWS, there is AWS Fargate for multi-clusters. Can this be done with OpenShift or the choice of your production tool? Not sure you know.
I honestly don't know. I've never done it and never looked into the specific approach.
Yeah, I think in the end of February we have a serverless expert with us, so this might be a good question for him. Okay. I'm gonna take that with me, but for now this one remains open.
Okay, sorry, just no problem. Yeah, sorry that I can't answer it.
But there's more.
Okay.
There have also been questions: is this code compatible with any application, or should it be changed? And if so, what needs to be changed?
So I guess that's regarding the Tekton pipelines. So usually with Tekton, you try to be as generic as possible, which applies for the task and the pipeline itself. Sorry. But of course, for your specific needs, you will have to adjust the pipeline or the tasks. But I think a lot of tasks that are used in Tekton, like the git clone task or the build task for the Docker image, that can be reused for nearly all applications because that usually is the same step that is be done. But actually, the build pipeline here, if you have the exact same steps you want to do, so fetching the application and manifests, building the image, and then updating the manifests, you could reuse this for other applications as well. You just need to give another input in the pipeline run definition. So just change the values to your needs, and then you can reuse this for your application.
Cool. And Sebastian, do you actually use any debugger tool? Or are you just as smart?
For this specific stuff that I show, no. Actually not. With Tekton, for me, it was a lot trial and error. But specific debugging tool, I don't use yet, no.
Okay. And there's also a question, since we already talk about Tekton and OpenShift. So this one is a really cool one. Jenkins X versus OpenShift pipelines versus Tekton. How do these solutions compare to each other? Are Jenkins X and OpenShift pipelines optionated Tekton, much like OpenShift versus Kubernetes? What's the additional value actually of OpenShift pipelines or Jenkins X compared to plain Tekton? That's a cool one.
Okay, yeah, that's really a cool question. Let me start with the OpenShift pipelines compared to plain Tekton. There's not much differences here. I think so. One of the cool things with OpenShift pipelines is you have already predefined cluster tasks. I can show it quickly. So you have tasks that are already defined that you can already use in your pipelines. Okay, it loads quite long. So here's a list of tasks like the git clone tasks that we also use. You have some Maven tasks, the build image tasks. I thought Kaneko would also be in here, but it isn't. So that's one of the advantages of the OpenShift pipelines. If you do it plain Tekton, you will have to install those tasks yourself. There's in the Tekton GitHub, there is a repository where some tasks, a lot of tasks are given, which can be installed from there. Also, one advantage is the UI for Tekton. So usually, if you just install the Tekton pipelines, you don't have a UI, so you will manage it on the CLI. There is a Tekton UI that you can install separately. So actually, that's given by OpenShift directly. It's quite nice to have this UI and where you can also follow your tasks and all the logs of all steps. That's quite good. But apart from that, actually OpenShift is doing plain Tekton. So you apply the same files to OpenShift as you would use for plain Tekton setup.
Okay.
Then for Jenkins X, I've played around with Jenkins X a few days, and it is using Tekton under the hood, but you have a lot of abstraction on top. So you don't need to. Usually, your Jenkins X pipelines look a lot cleaner than your Tekton pipelines would look for the same task. But the disadvantage then is you don't know what is done in the background. Generally, for Jenkins X, there's a lot of stuff that is done automatically where you need to find out what is done, and if something goes wrong, you really spend a lot of time debugging it. But generally, I think it's not a bad idea to abstract Tekton pipelines because it can save you a lot of time. But I think Jenkins X is, well, it's not purely a CI engine. So Jenkins X is also having its own GitOps pattern in the tool itself with pull request based GitOps actions. So it's a bit more advantage and covers a lot more parts of your workflow than just Tekton.
Thank you. And as I see the build image task running in the background, there is a question: does Builder still need to run in privileged mode for the Docker builds?
That's a good question. Maybe we can have a look here and see it. Usually I use Kaneko, and I also used it in the demo. I just replaced it with Builder because it was given by the OpenShift pipeline or cluster tasks. So I'm not sure if it's still the case, to be honest. Okay, I think it does not make sense to go through this now. It should be at the bottom. Okay, sorry, I really don't know right now.
Yeah, maybe we can look it up and I can write it as a comment later on.
Okay.
There, the people really want to know a lot of things today. So there's more questions. Are you ready for more questions?
Maybe some quick interruption, so we can just finish the demo and then we can go back to the questions. So
one more thing, Andreas just said there he saw it. The builder one is still privileged. It says privileged group. There you go.
Okay, thanks. So the pipeline now is done. So we built the image, we replaced the image in the deployment manifest, and then we pushed the changes to Git. So if we have not set up any webhook for ArgoCD and GitHub, it will take some time to be synced. Actually, it's just doing it now, so you can see the progressing. So it fetched the changes. So this is still the old one. You can see here the replica set has the revision 1, and after our deployment, we have a replica set with revision 2. And now the pod was updated as well with our image that we've created. So in general, ArgoCD has checks the repository every three minutes for updates. So that's the default. So it may take 3 minutes for the application to be updated, or you can do it manually by just clicking the refresh button. Okay, so that's it for the demo. I hope you got some idea on how this works now with Tekton and ArgoCD. And I'm ready for the next question now.
Very cool, Sebastian. Thank you. Can you say a word about how you would manage the multi-tenancy with ArgoCD? And Noshin also said, I know about project, but is there any way to prevent using a specific project in the Git with a team to limit the access?
Yes, so exactly. So the project is the way to go to separate the tenants. So you define projects, and with the role-based access control, you can give the team access to the specific projects that they need to work with. Since you can, so generally what you can do with ArgoCD as well is you can let the ArgoCD setup also be managed by the GitOps pattern with ArgoCD itself. So you can let ArgoCD update itself with GitOps. So this means everything that we defined for projects or access controls and all the stuff is defined in Kubernetes resources. So you can set up all your specific role-based access controls and projects in Git and let it be deployed and managed by ArgoCD. I hope this answers the question. I've actually not. Yeah. Okay.
So as we are all 1 minute away from the top of the hour, one more, or at least actually 2 more questions.
Okay.
What's your experience with layer caching for builds? Build X registry caching is pretty nice. Can something like that be done with Builder 2? Especially caching the intermediate images in a multi-stage Docker build.
Okay. Yeah. Yeah. Caching with Tekton is a good question. There is the concept of workspaces with Tekton. I can show it in our setup as well. Somewhere we should see some. Here there are workspaces. So in the end, workspaces are like volumes. So you can for a workspace, you can define persistent volumes. So for your build setup, you would define a persistent volume that has, that's persistent. So if you run your builds and your multi-Docker stage builds, it should cache all your images and intermediate images, so that not every time you build, it will pull everything, and so it will use the cache to build the image, and the build time will decrease a lot. So actually, that's like you can see it here. You have a volume template, and you can just like you do it with other stuff in Kubernetes. You can define persistent volumes and use this for your Tekton builds, and then use this as a cache for your Docker builds.
Sebastian, thank you so much. The last question is more an operational one. Oh, sorry. My kids are just joining. They want to see you too. So the last question would be if you could actually do share the repository. If it's free, it would be cool if you could like post the link in the chat or something, or give it to me and I post it to the bottom of the session.
Yeah, sure. Give me a second. I actually have to check if they are publicly available. If not, I will do it after the demo. So expect it to be available latest tomorrow publicly, so you can have a look.
Thank you so much. And with that said, thank you again, Sebastian, for being here with us today. I think it was a really nice demo, and I believe the attendees thought so too, because we got a lot of questions, and they have been really active in the chat. So for everyone else, please, if you have the time, take our survey. I'm going to post the link in the chat right now. And don't miss out on the last session of our Tech Talk series with ConSol. Olaf Meyer is going to talk about service meshes on January 27th. So please join us there as well. And Sebastian, thank you again for being here with us today. And
thanks for having me.
I wish you all rest of the a nice remaining rest of the day. And I'm going to close the session now. Thank you.
Okay. Thanks.